So I have a current draft of exam 2 in front of me right now. So as always, things may change a little between this and the final draft. As of right now, there are 26 questions on it, but this is at least 90% exactly what you're going to see on Thursday. So thing number one is, of course, as always, read the important general instructions at the very top. And then you can expect a question or two from chapter 8a. That's where we got the fundamental time value equation, and we were looking at what we call lump sum problems or two cash flow problems. And the equation that we use for any two cash flow problem or lump sum problem is FV equals PV times 1 plus R to the T. You can do algebra on that to solve for any quantity, PV, T, R. So expect a couple of problems where you'll have to apply that equation, the lump sum equation, or the fundamental time value equation, to solve for FV, PV, R, and probably not T. You definitely need to know qualitatively how a cash flow diagram works. So expect a question or two where you're given a cash flow diagram and you're asked to say, who is it for, a borrower or a lender? And then we did talk about perpetuities, and perpetuities are these uniform cash flow problems where the uniform cash flow that the lender get goes on forever, right? So the key with perpetuity is forever. We had a simple equation that related the present value of a perpetuity to that uniform cash flow and the interest rate or the discount rate of the problem. So I could ask you for the present value, I could ask you for the uniform cash flow, or I could ask you for the interest rate or discount rate for those problems. We also talked about growing perpetuities, so you should expect a growing perpetuity problem. Growing perpetuities go on forever, but the cash flow that the lender gets every year grows every year by an amount G. And we did a couple problems on that. You had some homeworks on that, so you should be able to solve a growing perpetuity problem. And we should be able to, you should be able to solve a general sort of cash flow problem that looks like this. We did a bunch of these problems where there is a PV tote or CF0 in the beginning, and that cash flow in the beginning is going to grow into these two cash flows. So you need to be able to solve for, in general, the PV tote in this case. And also I could ask you to write an equation down for R in a complicated problem like this. I wouldn't ask you to solve for R, but you should be able to write down the equation that PV tote is, in this case, something like this, but it's always just the discounted value back to T equals 0 of every cash flow, one at a time, and then added up. So that's going to be CF 1 over 1 plus R to the 1 plus CF 2.5 over 1 plus R to the 2.5. So I will expect you to be able to write down an equation like that, showing that you understand that each cash flow gets discounted back to T equals 0, then they get added up to give you PV tote. And then once you've done that, I could ask you what R is by making it a multiple choice problem and giving you 2 or 3 examples to plug in for R. And then the one that makes left-hand side equals right-hand side is the R that you want, the interest rate or discount rate that you want. So then we looked at annuity problems. So annuity problems are those uniform future cash flow problems. And those happen in a lot of circumstances. Those happen in mortgages, other areas like that. And in those problems, I can ask you for the CF0 or the PV tote, or I could ask you for the uniform cash flow. So expect at least one problem like that. And then we also talked about annuity due problems. So annuity due problems are also uniform cash flow problems. And the distinction with annuity due problems is that the borrower is paying those uniform cash flows at the beginning of each period instead of the end. So think about it like rent. Those of you that are renting right now, you know that in the month of April, you had to pay April rent at the very beginning of the month. So that's an annuity due form of contract, right? So for us in this class, annuities due are identified by the phrase annuity due or the word lease. If you see either of those two, it's an annuity due problem. And we'll solve an annuity due problem and an annuity problem later on today. Then we moved on to equivalent annual interest rate. So you need to know that, and let's write that down. Equivalent annual interest rate. That's the amount of interest you're going to get over a year, irrespective of what the compounding period is given to you and the time measurement given to you. So the EAIR is equal to 1 plus R to the number of periods per year minus 1. And then with some of these problems, when we're looking at different compounding periods, you'll be given that horrific, horrible, needs to be squashed like a bug APR, right? So for the APR, the first thing you want to do is squash it like a bug, right? So the APR is equal to R times the number of compounding periods per year. And what we're interested in is R. So R is always equal to the APR over the number of periods per year. And this is what we call our native R. So expect 1 or 2 problems where I'll give you a native R in, say, quarterly compounding period, and you'll have to compute the equivalent annual interest rate. In that case, you just plug that in. Or I might give you a problem where I give you the APR and ask you effectively for the equivalent annual interest rate. And that's just a simple 2-step thing. You see that APR, squash it like a bug, get the native R, and then use the native R to get the equivalent annual interest rate. And a good type of problem to demonstrate that you understand how this works is when we have 2 different banks offering different savings account. One says they have an APR of 8% compounded semi-annually, and the other bank says we have an APR of 9% compounded annually, okay? And you're going to have to say which one is best. So you have to know, are you the lender or the borrower? That's the first thing. Because if you are the lender, you want a higher rate. If you're a borrower, you want a lower rate. So that's number one. You have to understand that. And then you just have to put both of them, both of these offers in EAIR form. And if you're the lender, you pick the one with the bigger EAIR. If you're the borrower, you would want one with a lower EAIR. Okay, and then we finished up chapter 8 with looking at semi-annual pay bonds. That's really important. So expect at least 2 questions on semi-annual pay bonds. The key things with semi-annual pay bonds was that I gave you 1 page that had all the key definitions. You need to know those definitions or you'll get all 2 or 3 of these questions wrong. So make sure you know all the definitions for semi-annual pay bonds. And then we looked at semi-annual pay bonds in 2 situations, at issuance and then trading in the marketplace. And we looked at how to get in particular, the yield to maturity in both of those situations. It was really easy and straightforward at issuance. It was a little bit more involved when trading in the marketplace, but we did a couple examples of that, gave you a concept quiz on that. I put up another additional practice problem on that, so you should be able to do that if you know the definitions. So semi-annual pay bonds, know the definitions, they're all there for you on 1 page, know how to treat them to get a yield to maturity at issuance, know how to get a yield to maturity when they're trading in the marketplace. And hint, 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 an at issuance problem will say something like issuance or just issued today or something like that, and trading in the marketplace will say something like it's trading in the marketplace, it was issued 5 years ago, that type of thing. Then also in chapter 8, we looked at far forward values in an account of cash flows we're going to get in the future, right? And the situation there was, let's write this down again too. The situation for these guys is we are sitting here at t equal 0, and we're going to get some money in the future, and let's call this t final here. We're going to get a deposit here and another deposit here, and we may want to know what's in the account at this time t final, or we might say something like we're going to take all that money and withdraw it at that time t final. So the key thing with this is, let's say this is 1, 2, and this is 3, and this is CF1, and this is CF2. The key point of this is you take each of these cash flows individually, and you say, how much time does this cash flow have to grow, right? Don't have it now, so it's not going to grow starting at t equals 0. We're going to get it at 1, and it goes to 3, right? So for this one, this is going to be equal to, this one is going to grow by our interest rate, R, for how long? 3 years minus 1 year. And then you do the same thing with the next cash flow, and then you just add them all up. Okay, so don't let those scare you. It's very, very straightforward. You just say we're going to get these cash flows in the future. We're going to measure the total amount we have at some farther future time. Each one is just growing with the fundamental time value equation by the amount of time it's in the investment vehicle. Okay. All right, let's see what else we got. And then from chapter 9, we looked at treasuries being risk-free securities, right? And we found that risk-free securities are actually, they have some risk. Why do we call them risk-free securities? Because everybody else does, and they're the least risky things in the world, but they do have risks. We found they have 4 risks. They have duration risk. Everything has duration risk, and that's built into our time value equations. And then what else did treasuries have? They had inflation risk, they had interest rate risk, and they had default risk. Very small probability, but default risk. So we had to know and understand that. And then in chapter 10, most of chapter 10 was about that opportunity investment risk model. And to get that set up, we had to know our mission, and we had to find an opportunity cost investment. And then the opportunity cost of capital was just the interest rate or the discount rate for that opportunity cost investment. So conceptually, the key thing there was, if someone has an investment mission, what would be the best opportunity cost investment, right? And we said that that had 3 components, right? Whatever that opportunity cost investment was, it had to be a diversified portfolio of stuff. It had to fit within our mission. It had to be in the same investment milieu, the same investment galaxy, and then it had to be the same security type, right? If our mission is we invest in bonds, the opportunity cost investment has to be a portfolio of bonds or loans, some sort of contractual stuff, right? If our mission is to buy stocks, the opportunity cost investment better be something about stocks and not bonds, right? So you need to know those 3 criteria. And then we went on to 11A, and heads up, 11A material, very important. We're going to use it for the rest of the term, particularly the NPV method. But in 11A, we learned the NPV method for evaluating financial projects. We learned the BCR method, and we learned the IRR method. So expect a question or 2 on each of those methods. And remember our rules for these methods. The NPV method says if the NPV is greater than 0, it's a good project. If it's less than or equal to 0, it's a bad project, so you don't want to go ahead with it. And the BCR method said if the BCR ratio is greater than 1, it's a good project, you want to go for it. If it's less than or equal to 1, it's a bad project, you don't want to go for it. And then finally, with the IRR method, we said if the internal rate of return is greater than our opportunity cost of capital, or ROCC, we want to go for it. If it is equal to or less than our ROCC, we don't want to go for it. And the last thing that we got there was for the situations that we're applying these methods in, all 3 of them have to point in the same direction. So if the NPV is greater than 0, the IRR should be greater than the cost of capital, and the BCR should be greater than 1. If they don't all line up, what does it mean? It means you made a mistake in your calculation somewhere. So you got to go back and check all 3 and see which one was wrong. And so for the NPV and the BCR, I can ask you in a pretty straightforward way, just calculate the NPV, calculate the BCR. So for the IRR, you have to know how to write out the equation for that. And remember, the IRR is the interest rate or the discount rate that makes the NPV equation equal to 0. So you just write out the NPV equation for the problem, set it equal to 0. You're going to know everything but IRR. So just put in IRR everywhere you have that unknown interest rate or discount rate, and then what? I may check that you have the right equation, that you haven't screwed up writing down the equation, and then I might also say that I've got 3 choices for you of IRR, which is correct. That would be a multiple choice question. Of course, how do you answer that? You just plug in, and the IRR that gives you 0 equals 0 is the right one, right? And I won't do anything tricky like giving you 0.0 and then giving you 0.001, right? They'll be well separated. And the wording will be something like which is closest to the true IRR. So there won't be anything tricky about those. So also when we were talking about the NPV method, the NPV method is sort of the word in the light and the way because it always works no matter what the situation is. But we did talk about one important concept of the NPV method, and that was the increased wealth concept. So the dollar amount of the NPV, when you compute an NPV, that's a dollar amount, right? Or $1 million amount if we're working in millions of dollars, et cetera, et cetera. And what that dollar amount represents is how much wealthier we're going to be by choosing to pursue that project than doing the next best thing, which would be to throw the same amount of money in our opportunity cost investment. So it tells us how much better off we would be in a dollar amount in present value dollar terms today than throwing the equivalent amount of money in the opportunity cost investment. And that's pretty much it. So I've been looking at every question on the exam so far. There might be some changes, so you can't count on this being 100%, but I think that gives you a good representation of what to look for on Thursday. So let me stop this recording, and then we'll pick it up from there.